Ladies and gentlemen, I would like to welcome you all to this prestigious panel session about one of the most popular topics in oil and gas industry, modern technologies for offshore field development. My name is Süleyman Coşkun, working for Turkish Petroleum as exploration geophysicist, and it is an honor to serving as your moderator. Exploration strategies of most oil and gas companies increasingly changing to move offshore since there are still oil and gas fields waiting for being discovered. So innovation, creative and reliable fields development solutions make this area more challenging for oil and gas companies. Every step of the field development needs to be well organized and supported by technology and innovation. Today we have exclusive speakers on this very timely topic, and I am sure that we shall have outstanding presentations from our prominent speakers, whom I believe shall enrich our insights and knowledge regarding the theme of our panel. I would like to introduce our speakers first. Mr. Alexander Vasilyev, Deputy General Director of Operational Activity of GPN, Prizlomnoye Gazprom Neft. Mr. Milton Costa Filho, General Secretary, Brazilian Petroleum, Gas and Biofuels Institute. Konstantin Kornishin, Technical Regulation Manager of Technical Regulation and Corporate Scientific Project Complex Development from Rosneft. Alexander Lubnin, Deputy Chief Geologist from Vietsov Petro. And Dmitry Sheketov, Reservoir Engineer in Aker BP. Now, ladies and gentlemen, let's welcome our first presenter, Mr. Alexander Vasilyev, to give his speech.
Добрый день, уважаемые участники форума. Если не возражаете, я продолжу на русском, а слайды будут идти на английском. Сегодня я хотел бы рассказать об опыте освоения приразломного месторождения. Многие, наверное, уже из вас слышали о платформе приразломная, которая находится на платформе на российском шельфе. Но, тем не менее, проект мы продолжаем разработку месторождения, хранение нефти, отгрузку.
And shipment and storage of oil and development. So my brief information about the project. Gazprom Neft Shelf Company has the license to develop the Priraznom field. Recently, we had a transformation, and the Gazprom Neft Shelf Company became the owner of all the licenses for Gazprom Neft Company and for those areas that are in the offshore area of the Russian Federation. And Gazprom Neft Sakhalin company also became separated. They are going to deal with geological exploration, and there is Gazprom Neft Prirazlomne company that will serve as an operator of the project. On Prirazlomne started its history in 2012 with the extraction of the first oil at Prirazlomne platform. The peak of extraction will occur in 2022-2023, about 5 million tons of oil per annum. This slide shows the geological map of Prirazlomne field. Sea depth is about 19 to 20 meters, and the platform, if you look from above, has an area of 2 football fields. The operation time period will be about 36 years, with the possibility of extending it, and extractable, recoverable oil reserves are about 70 million tons. Climatic conditions in the area of the platform are quite severe. temperature minimum might be minus 50 degrees centigrade. In the area of the platform, there are about 22 storms a year. Wind speed is 8 to 9 points, and wave height during storm is up to 9 meters. Last year, we had a storm that happens 1 in 50 years. Up to 15 meters was the height of waves. We also have drifting ice about 7 months a year. Today, we have the 25th of June, and ice is still drifting there. What are the success factors that are the key for the success of Природословная project? Primarily, this is technological efficiency, safety, and environmental friendliness. Of course, people are behind all this. Technological effectiveness, it is clear that in order to produce in the Arctic, we need to apply the advanced technological solutions. Previously, we couldn't do it, and now there are methods which make it possible to do it and to work safely. We have a well stock, 32 wells. We have drilled 19 wells by now. 11 of them are producing wells, and 6 are pumping wells, and 1 special well for sludge drilling is with 1 drilling rig. At the same time, we have the drilling process, oil preparation process, storage, and shipment. All the producing wells are equipped with electric centrifugal pumps of high productivity, and the expected length by the end of development will be about 200 kilometers. Then the technological parameters of Природословная platform accommodation block with a capacity of 200 people. There is a system of devices of comprehensive shipment of oil, and on the platform there is a wave deflector and ice deflector. It is clear that the wave deflector saves against waves, and ice deflector helps to combat with the burden of ice. Caisson has a capacity of about 160 cubic meters. The oil storage tanks are 12. A caisson protection system is represented by 2 deflectors, and we also have the low part of the base of the platform with a double layer of steel. There is cathode and anodic protection and paint covering the weight of the platform, including ballast, is more than 500 tons. That can be kept safely, and we can continue the operation despite the ice loads. This slide shows the caisson control system. We collect data from different sensors, which determine the seismic activity of the platform, measure the incline of the caisson, ice loads on caisson. They measure the burden of the platform on soil and water pressure as well. Especially for the project of Природословная, we built the fleet. We have 2 shuttle tankers of ice class, each of them with a dead weight of 60,000 tons, and 2 multifunctional icebreaker vessels, Vladislav Chizhov and Yuri Topchev. In addition to these vessels that were built for the project, each year we involve different other vessels, supply vessels, and rescue vessels as well, which are operating around the clock near the platform. Factor number 2, industrial safety. The company places major emphasis and time on the safety. In the next slide, you can see the evacuation and life-saving system for the personnel in case of some unforeseen problems. Evacuation bridges, 8 rafts per 280 people, and fire-resistant assembly point for 260 persons, where you can stay safely to 2 hours. High evacuation speed, we attain it by exercise, and we have 8 to 10 minutes when the personnel is assembled, and complete evacuation is within 40 minutes at maximum.
As one of the major means of evacuation, we have got 4 lifeboats for 264 people. Safety issues related to drilling. Here is the comprehensive set of equipment against blowouts, including preventers, spherical and blowout preventers, shutdown valve for all the wells, and on daily basis we have special security of blowout oil gutting out system. Safety in oil transportation, we have this green line which includes 30 different conditions. When we collect them all, we'll be able to start oil pumps. Its positioning of the tanker, it's also SDV system, and if some of those conditions is disrupted, automatically we stop dispatching oil. The logistics people are moving to Archangel city from Moscow and from St. Petersburg typically. Then for 2.5 hours there is a charter plane to Varandy where we have got transshipment base. And then by helicopter equipped for maritime operations, they are moved to platform that takes another 35 or 40 minutes. Oil transportation, first we used to transport all the way up to Rotterdam. Presently the amount of oil has been growing up, so a decision was made to store oil in tanks in Murmansk port, where oil transshipment is done. And then by tankers we transport oil to consumers. Supply base is also located in Murmansk, 980 kilometers away from the platform. The company has been using best practices in HSE systems, and it had also developed HSE case. It's a document. I think you know what HSE case is all about. Our platform has got #1 hazard class. It's hazardous production object. As in any hazardous site, we have got the risks of full-scale accidents. And as operator organization, we are responsible for development of safety measures and to provide for several barriers to prevent accidents and to prevent the escalation, provided the incident happened. The company focuses its attention on the system of preventions of oil spills and oil spill recovery. We have got drills and exercise with our local partners who produce oil here, and with the help of specialized organizations having 24 hours vigil on supply vessels and at Varandia base as well. And we have got different scenarios to deal with oil spills, to recover oil spills. We have got scenarios of not just oil spill recovery close to platform, but also to protect shoreline close to Varandy and adjacent islands who are in the nearby. And last factor of success of this platform is the fact that it's environmentally friendly. The company invests a lot into environmental safety. We develop fry fish and release it into water body. We do monitoring or water seals and other ones, whitefish and beluga. We can see seals and salmon and beluga close to the platform. Sometimes polar bears come close to the platform. They recognize the waste, the bilge waters, and waste is pumped into a special well or brought to the shore. And we have got 4 safety devices to protect fish getting into the pump. Summarizing, I can say that the company puts together a lot of efforts, mindful of different geopolitical limitations and harsh Arctic climatic conditions, to carry through with the development of oil fields and do it in a safe way, caring about nature as well. Thank you.
Thank you very much, Mr. Vasilyev, for your presentation. You summarized your study in just 3 factors, and they are very important for all the offshore field development projects. Thank you very much. So now we are moving to our next presenter. I will invite Mr. Milton Costa-Filho to present an interesting study about pre-salt.
Good afternoon. Thank you for the invitation to speak here in the Future Leaders Forum 2019. So my presentation will be about the pre-salt fields in Brazil, achievements and legacy. This is, well, as you are aware, the current environment in the oil and gas industry is quite different from what it was in the first half of this decade. We had a robust demand growth and several supply constraints in a balanced market and high oil prices in the hundreds US dollars per barrel level. So since 2014, companies are adjusting their strategies and the industry is changing its focus to profitability, cost reduction, and active portfolio management. On this map, you can see the pre-salt province showed in a dark blue area inside the zone. It's located in southwest Brazil, and it comprises 2 sedimentary basins, Campos Basin and Santos Basin, both with first-class carbonate reservoirs below thick salt deposits. In the Campos Basin, we can find post and pre-salt reservoirs, and due to its already installed infrastructure, the pre-salt development was much faster. On the other hand, in Santos Basin, where pre-salt discoveries are larger and with higher productivity, there was no pre-installed infrastructure. There, the challenges are many. 300 kilometers far from the coast, 2,000 meters of salt layer, ultra-deep waters, complex carbonate reservoirs, but prices were even greater, with volumes higher than those on Campos Basin. In Santos Basin, the reservoirs are located in water depths ranging from 2,000 to 2,500 meters. And the salt layer itself has an average thickness of 2,000 meters. The reservoir's depth ranges from 5,000 meters to 7,000 meters, while the reservoir net pay ranges from 150 to 450 meters. As to better understand those numbers, one can note that the total reservoirs depth in the pre-salt fields is equivalent to the height of the K2 mountain. Nonetheless, we did not start from scratch. We relied heavily on our previous experience in Campos Basin, where we have produced oil and gas since the late 70s. To conquer pre-salt, hard work, heavy planning, strategy, discipline, knowledge, teamwork, focus, and determination were fundamental requirements, as well as intense investments in technology. Together with the supply chain, we developed or adapted technologies that have made pre-salt production technically and economically feasible. Pre-salt projects shown very attractive break-even. The expertise acquired over the years, together with our historical experience in deep water, enable us to develop it, taking advantage of the reservoir's high productivity. We have wells producing 40,000 barrels per day. There are many of these wells with this high productivity, and then we try to make significant project enhancements. As a result of those efforts, projects in Brazilian deepwater plays have become more competitive, and we are doing very well when comparing with other deepwater or tight oil plays. The forecast average break-even Brent price is under $40 according to Wood Mackenzie. Deepwater production in a very competitive pre-salt lifting costs below $7 per barrel of oil equivalent. The recent improvements in the regulatory and tax framework will also contribute to our cost reduction efforts. Like, for instance, different improvements in local content policy, renovation of fiscal incentives. Petrobras is not anymore a sole operator in this area. So these changes in the regulatory framework attract lots of new companies to participate in the pre-salt projects. So, and what are we doing? We are keeping investments focused on pre-salt areas, accelerating the pace of project implementation, as well as new technologies and project conception, contributed to a significant production growth, enabling to reach production around 1.5 million barrels per day in the pre-salt. Petrobras alone is producing 1.2 million barrels per day, out of the total Brazilian production right now of 3.3 million barrels of oil equivalent per day. And nowadays we have 97 companies working in the E&P projects in Brazil, being 47 national companies and 50 foreign companies. Petrobras' strategy for the pre-salt was divided in 3 phases. Phase 0, or the information gathering phase, was designed to obtain important and necessary information regarding reservoirs and their geological aspects, including well performance and area delimitation. We need to reduce those uncertainties. Phase 1A apply know-how in deep water production development, adapting to the pre-salt scenario. And phase 1B, we would increase production, applying proven technology and developing new ones. In our project's implementation, we have managed costs with good outcomes. In this slide, we can see 3 examples of that. Based on technology, high level of standardization, scale, and repeatability, we were able to shorten in 42% the ramp-up phase of the pre-salt projects in the last 7 years. In the subsea area, we have optimized 25% costs in Búzios and also 35% 25% in Lula field. Efficiency gains also accelerated well construction days by 51% in Búzios field since 2014. Pre-salt developments should receive almost $80 billion of investments in the next 7 years. In the next 5 years, only Petrobras will start up 11 new production systems, 7 of them at the pre-salt. Only the giant Búzios field will receive investments around $9 billion over the next 5 years. As you can see, each one of these production systems are FPSOs, and this is the current model of production in the pre-salt. Thanks God we have different weather conditions that my colleague just explained. So we have each one of these FPSOs, in average, they produce 180,000 barrels per day and 6 millions of cubic meters of gas per day. So you can see 2, 5, 10, 14, 16, 22 new projects on the coming until 2023. Each one of these systems costs around $2 billion. It's really very demanding. And in a moment of that the shipyards are completely overloaded of projects, so it's going to be very challenging for us to produce and to deliver these projects. But doing that, the expectations is as up to 2025, we are going to double the production of oil and gas in Brazil. So let's talk about one of the important factors that will help to develop the pre-salt, is the standardization. There we will put on stream many systems to produce the same reservoir, from the same reservoir. Also, many fields keep similarities to each other. So this scenario provides a synergy and opportunity to apply the same type of equipment in different projects, giving us the opportunity to optimize the inventory. This was a successful strategy previously adopted in Campos Basin, but on a smaller scale. The standardization of key equipment such as Christmas trees, manifolds, and flexible pipes enables cost optimization. Those upsides are better resource allocation and more effective risk management. On the supplier side, the benefits are scale of production, spare parts reduction, and reduction of engineering times. Relevant new technologies in subsystems were developed to cope with the pre-salt challenges in ultra-deep water, like the buoy of sustainable risers. Important well innovations to deal with thick salt layer, different contaminants, and reservoir characteristics were also implemented. Compact CO2 separation system and the first application of water alternate gas injection in an ultra-deep water field are also important pre-salt achievements. All these technologies have allowed pre-salt economic production. For the near future, what do we have on our radar? Here are some disruptive technologies that will help us to push forward the limits. Production digital twin. This will optimize interventions in our production assets through digital replica of the production systems. Subsea high separation allow us to enhance our technology of subsea CO2 and gas separation, reducing the gas-oil ratio of produced fluid. Safety supervisory system based on intelligent video analytics for potential hazard detection and prevention, and well plugging technology using heat emission. allowing us to reduce the cost of well abandonment. Also, autonomous inspection enable diverless inspections to cleaning and visual inspection of risers up to 50 meters water depth. Finally, I would like to highlight that the implementation of this portfolio of mega projects is a result of a teamwork. Oil companies, employees, partners, suppliers, service contractors, and academia that work together to deliver sustainable and successful projects. Thank you very much.
Thank you very much, Mr. Filho. I hope the new technologies will also help us to find new discoveries from the pre-salt structures. So thank you. And our next speaker is Mr. Konstantin Kornishin, and he will talk about another aspect in offshore field development. We will have an interesting presentation about experiments in iceberg towing. Please welcome Mr. Kornishin for giving his presentation.
Good afternoon, dear colleagues. I will make my presentation in Russian, but my slides will be in English. The theme of my presentation, iceberg towing, experiments as a part of ice defense system. And just introduction, it is clear when the Rosneft company started working in the Arctic, and it is the largest subsurface user, the main risks of working in Arctic, both for exploration, drilling, and then for operation, is collision with ice formations, primarily for the current Barents Sea. The collision with icebergs is important, and hence in the company we place major emphasis on minimization of the threat, and the presentation will be dealing with it. The main method of combating icebergs is their removal or tracking icebergs, tracking the drifting and following the subsequent drifting, and the system of iceberg defense is developed not only in Russia but also in Canada. But I can note that the works on the studies of icebergs in Novaya Zemlya by Rosneft were conducted starting with 2012 for about 6 or 7 years, and immediately we involved the so-called genetic method of studying icebergs. We study icebergs from the moment of their formation near the glacier to the time when they are towed, the entire cycle. Just a few words about studying glaciers. It is clear when your field is located in close proximity to the producing glacier, you have to know precisely what icebergs it produces, what are the sizes of the icebergs, and how they propagate. We used the thickness measurement of glaciers. On the glaciers, we installed buoys and to determine the surface velocity, and we took aerial photos of all the icebergs at the glacier front, and we studied the zones of iceberg production. You can see them in this figure shown in lilac. These are the zones where the maximum formation of iceberg proceeds. Some words about the area of studied glaciers. The company studied more than 70% of producing iceberg-producing glaciers in the Russian Arctic. You can see light green color is what remained. In principle, in France, Joseph Land, and in Severnaya Zemlya, in Novaya Zemlya, the studies of glaciers have been completed. If we compare it with Canada, similar work was conducted in Greenland. inland area. Just a few words about the study of icebergs. There are observations from on board of icebreaker, airborne observations, system of meteo stations, and the system of buoys installed in all the seas of the Russian Arctic. That was the first step to determine the weather conditions and also to determine their oceanological characteristics. And after that, in 2016 and 17, Rosneft company jointly with the subsidiary, the Arctic and Antarctic Research Center in St. Petersburg and the Institute of the Arctic and Antarctic considered major expeditions to study the possibilities of deviations of the icebergs. They used the Russian icebreakers, diesel icebreaker Capital Dranitsin and Novorossiysk icebreaker. During these works, they towed 36 features, and they measured practically all the parameters which are accompanied by towage. They determined the force that is necessary for tugging and the iceberg movement parameters and the vessel movement parameters, kinematic and dynamic parameters, as well as a 3D model was built for the iceberg, and a buoy was mounted on it, and they determined the parameters of the environment as well. They tested towing of both by rope and by net. In the next slide, you can see the area of work on towing the icebergs in the 2016-2017. Practically in all parts of the Western Russian Arctic, they were conducted. Just several photos, how it looks from air. This is from a vessel board. It is clear that the technology was developed in Canada, but I can tell you immediately that the conditions of the Russian Arctic are slightly different. So the technology and its application were modified. Not only modified, but a new scientific approach was proposed to reduce the iceberg hazard at all the stages. One slide is showing how it is done, how the vessel throws a rope and then collects it, after which the process of towing starts. That is the first stage of towing. The main technological results on which I would like to dwell, the mass of all towed icebergs exceeded 5 million tons, and of local results, the maximum mass of one iceberg was 1.1 million tons, the minimum mass 3,000 tons. Controlled drift were conducted. You can see the geometric symbol along the trajectory they towed their iceberg to Franz Joseph Land. The maximum iceberg movement per day was 50 miles. That made it possible to guarantee its removal from any oil and gas production structure. Maximum force applied from the rope was 100 tons or 1,000 kilonewtons. The minimum visibility at maneuvering 300 meters, also a good result. Maximum wind speed 15 meters per second during towing, and probably for the first time this work was done and published in open press. So we were the first to do that. We had several successful towings in early ice with concentration from 8 to 10. And we also managed to have simultaneous towing of several small icebergs. I would like to mention especially that during towing, not everything is so simple. It is not just you just catch and drag. You have to think. In this slide, you can see a 3D model of an iceberg that was plotted, how it is towed, and the trajectory that we had. If the vessel trajectory is a straight line, you can see that towing of the iceberg is accompanied by significant fluctuations. which have a drastic effect on the requirements to the vessel, on changing the route. If you do not precisely choose the route, you will have that periodical process that will deteriorate the conditions of towing. The theoretic notions about towing prior to our works were primitive. During towing, gradually the effort increased, thus we could determine characteristics of iceberg drifting at different velocities. Mathematical model that was quite primitive. It was plotted from the viewpoint of mathematics. Everything is okay, and an unusual result, which is a surprise both for the Russian Arctic and for our Canadian colleagues. As a result of our experiments, it appeared that the resistance coefficient, the dependence between the force and the rate attained by the iceberg, is not linear. So it is determined by Reynolds number. That is a significant factor when we develop iceberg safety. It is reduced from 8 to 2 with increasing towing speed, and below you can see a certain assessment of the speed, how I can move an iceberg. If I use 1,000 kilonewtons, it is clear that after a major integrated expedition was organized, the mathematical modeling of the results, they were coincident. One of the slides shows how specifically in the software we realized that process. I can tell a few words about the alternative methods of physical impact and combating icebergs. In addition to their towing, for the conditions of the current Barents Seas, we can destroy them by gradual circulation around them by a vessel. If you just move around the vessel of the destroyed shape, it will be totally destroyed, washed out, and will be of no hazard for your structure.
Прошу прощения. Извините, значит, так, несколько слов хотела бы сказать.
Just a few words about towing icebergs under ice conditions. For towing icebergs, if there is ice on water area, it is also possible. And for ourselves, we had restricted the range of use of 25-30 centimeters. If the ice is not yet 20 or 30 centimeters, it can be towed. If ice thickness in the water area is more than 30 centimeters, towing of the iceberg by that method by one icebreaker will result in certain difficulties, and the main method of ensuring safety, it couldn't be recommended. Thank you for your attention. I am ready to answer your questions.
Thank you, Mr. Cornishian, for this interesting and attractive presentation. And I have a quick question. As I know, there is a well-established ice defense system practice in Canadian shelf. So why did you decided to develop your own system as well?
I will answer in Russian. Probably there are two main reasons. First, the technology which is used on the Canadian shelf is not based on major mathematical development, and that is sort of a cookbook. It is primarily based on the statistical processing, but initially we wanted to build our system on understandable physical principles. So towing of the icebergs is a dynamic task. That is the first part. We were not quite happy with the Canadian system. And secondly, the conditions of the Russian Arctic for which we developed it differ from the Canadian conditions. We have often towings in case of ice in the water area, and our icebergs are much more movable, though they are smaller. And thus, eventually, we had to develop our own model and our own approach. And probably one more thing related to the first statement. If we speak about the Arctic science, we have to have Arctic science and not just a list of formulas how to catch iceberg correctly. We have done it during 8 years, and we were successful. Thank you.
Thank you very much. Now I will move to another speaker. He is Alexander Lubnin. Please join me to welcoming him to the stage.
Good afternoon, dear participants of the forum. My paper will be dealing with the experience of development of offshore deposit by Vesa Petro company. That is a joint stock company with a Vietnamese partner is Petro Vietnam company. The Russian partner is Zarubezhneft company. Vesa Petro develops the fields on continental shelf of Vietnam in the southeast of Vietnam Sea. Overall, they work on 7 blocks, on 5 petroleum and 2 gas. The main block is 0.91. That block gives the highest profit to the company, and in this block, the White Tiger, Belly Tiger field is located. They are also working on blocks 0.93, 0.9312, 0.2.9, and 16.115 on 0.43. Gas is produced. Vesa Petro acts as an operator, and on block 1211, Vesa Petro is operator in geological exploration. I will tell you a few words about the history of the company. The company was set up in 1981 by conclusion an intergovernmental agreement between the Soviet Union and the Socialist Republic of Vietnam. From 1984 to 1985, a geological exploration was conducted, and oil and gas presence was determined at Lower Miocene deposits, Lower Miocene or White Tiger deposits. In 1986, we started the commercial development of the Lower Miocene deposits of White Tiger. In 1987, there was a miracle for Vietnam and for the global community. We found oil in the crystalline basement of the White Tiger. Essentially, that had a strong effect on future development of the company, and it determined its successful operation for many decades to come. From 1988 to 2001, the company develops actively. The accumulated extraction is 100 tons, and Dragon Field was commissioned from 2002 to 2012. Three additional fields are developed on block 091 and produced 200 million tons. From 2013 to 2019, the activity was expanded, and they started development of the neighboring blocks. They have started commercial development of gas field at block 0.43, and this year production was started from block 0.09312 Beluga. In order to understand what are the tasks faced by the company and how it solved the task, I have divided the history of work of the company into 4 periods, and at each period I determined the main focuses with which the company was working. From 1984 to 1994, they introduced large areas of White Tiger field, they drilled wells in the basement, and the geologists mainly concentrated their work on optimization of the well profile. At the same time, in that period, they created infrastructure of the surface arrangement. They used marine fixed platforms, and they formed the offshore facilities, and these facilities now make it possible to work with operational expenses about $8 per barrel. And in order to determine the optimum demand for operation of the wells, having that technology development, different types of production were determined. In 1995, there was a growth of production due to drilling in the basement. White bear, white rabbit, dragon fields were commissioned with the reserves about 10 million tons. At the same time, in order to increase the efficiency of the work of the company at such smaller fields, they start using lock conductors, and for drilling, self-hoisting drilling rigs, because sea depth within shelf is about 50 meters. In order to increase the efficiency, they start using technology of separate exploitation. From 2013 to 2017, this is a period of recognition. There was lower production from the basement, so they had to find new sources of resources. And during that period, it was decided to organize a high-resolution seismic 3D 4C, and that result is now determining the development of the company.
And packing drilling is done due to the construction of extra slots at block conductors. To optimize gas lift, we introduce technological modes, and we have good tools for rapid analysis of well operation. Based on 3D 4C seismic results, we identified those small, like 1 million ton of geological reserves traps, so that develop those small sites and blocks. And it's a new challenge for us from the standpoint of infrastructure. We have been in search of the technologies for cheap unmanned platformed, lightweight from the top side. Over almost 30 years, the company has been in existence. We improved electrical centrifuge pumps quality. That way we could be energy efficient. We'll shift from gas lift to electrical centrifugal actuators and pumps. Now we are dealing with different tasks: geology, development, production, infrastructure. I'll start from the geology development. Major block 9 reservoirs have two types. It's crystalline basement. Crystalline rocks are granitoids, and major reserves are in microcracks, but flow rate is based on caverns or microcracks. Permeability could be high enough there, and it's 2.5 kilometers of this basement, which is oil proliferous. There are terragenic depositions, oligocene and miocene depositions. Actually, first the basement was developed and it was water flooding between 1994 and then 1998. There was the bed pressure going down when water was injected into the lower part of the basement, which impacted benignly dynamics of the bed pressure. And presently, such a way of supporting bed pressure in the formation until the situation that it's only in the top and burden part of the basement where this flood is. In order to forecast the flow rate of those wells, flow rate of some of the wells is almost 400 tons. That stood it's 10-12 millimeters. It was necessary to develop good instruments to make urgent decisions to regulate the operations of the wells. We did it based on numerical analytical models. That way we can forecast the dynamics of water cuts in the wells and to make urgent decisions to change the modes of operations for wells to identify the best pins here. And we develop the dynamics of those water cuts. Depressions are very small, like several atmospheres. Only the change in the diameter of the pin can reduce the conus influence. IPA 7004 well shows how the reduced diameter of pin to 10 millimeters enabled us to get extra oil production from the well and to reduce water cuts from 10% to 0. So, in 2015, we understood that the basement, the entire major basement is almost depleted. So we shifted to turogenic depositions. As the results of the seismic studies, we identified productive traps. 3D for seismics is high-resolution seismics, and the blocks which were considered not to be productive. And now we see them in those traps. So we found some fields like White Cat field, which will develop. We have it in our plans. The seismics 3D, 4C, apart from structural traps, we identify non-structural traps as well. It's based on the analysis of seismic attributes for a specific. So we have been working along those lines as well, making those computations. It's crystal clear that those new traps are small ones. We won't find anything like another white tiger. So all the previous decisions for infrastructure, block conductor, or fixed platforms will not be applied here. As to those small blocks, we can develop them only when we increase those cells on already existing block conductors. Those cells previously were not envisaged by the project, but detailed analysis of structure, peculiarities of block conductors enables us to make those extra cells. Another direction is using a super-light unmanned platform. I would like to demonstrate the way those two directions are developed by us. For example, we identified prospective drilling target west of the developed field. Actually, the reserves there amount up to 800,000 tons. Drilling well just in this drilling target is rather risky. So when we design the profile well, we always select the reserve zone in such a way. So in case oil and gas proliferates, those drilling targets are not oil and gas proliferates, we can do the kick-off. So here oil proliferates property of this drilling target was very good, so we drilled extra well. As the result of the drilling of the western part of the block, this target, drilling target, was not there, so we kicked off the lateral into this prospective zone. That way we right-sized their costs, our costs of production. Next, using unmanned platforms. In 2017, we discovered a small field, White Cat. We developed the system, we identified the system of development. We decided to use unmanned platform. In this oil, we identified small marginal place which is divided by tectonic fault into two blocks. MT1X and MTT1X in the well. And in order to increase the reserves, which amount up to 20% of the major deposit, we will drill more on this gas field in order to increase the efficiency. Another direction we embarked upon is just working with those stocks. There is circular system, there is gas lift, so every day something happens. Pressure goes down, then the pressure is reswitched to upper valves. Then the pressure goes up. It's possible to leverage it. If it's 300 wells, it's not possible to analyze the entire stock of wells. So we introduced technological mode to operate that as well. It's used in Russia in such a way that automatically we identify the potential of the well, to identify automatically problem wells, and technologists will develop work over in order to increase the potential from all those wells. This technological mode is quite predictable, and the pressure outside the borehole correlates with the results of hydrological studies. Automatically for each well we identify the optimum gas lift flow rate and minimum and maximum flow rate and pressure outside the borehole. This technological tool is used to optimize production when there are limited volumes of compression capacities. We should optimize gas flow rate along the wells to maximize oil production. We use the methods of analysis using different technological modes, and slide shows that we can increase the production from one platform by 3%. So we work at the optimum level. But with the development of electrical centrifugal valve and increasing the period between the workovers, actually we use gas lift as well, and we should be fully aware of our potential. We do the completion of wells with ESP, and presently 8,000 tons is produced by gas lift, and we have to optimize all the wells. Provided we didn't have limitations on compression, production would only go up by 8%, and the pressure from 119 would go down to 107 atmosphere. That is the outside the borehole pressure. When we analyze the stock of all the wells, we can see that 265 wells provide us with the increased production, but it's due to very few wells, due to some limitations because of the condition of the stock and so on. We do feasibility study, so actually it should be at least 50 tons for the enhancement of flow rate. But actually we have got about 10% of all the wells which we should equip with ESPs to get total increase in 2,000 or 4,000 tons. We have embarked upon the completion of the wells with ESP, and for 5 wells we're doing that mostly. By summarizing, I would say that presently joint venture with Petro stabilizes the production of the enterprise. We use all the state-of-the-art technologies from different countries, and we do the solution of the task because we have got 40 years experience for our enterprise, and we do geological exploration. It's application of modern approaches for seismic interpretation. We also search and test for potential traps or structural, non-structural type. From the standpoint of production, it's sustained work. We optimize the gas lift performance. We do the completion of wells with ESP, and we use EOR methods for developed reserves. So that about wraps it up. Thank you very much.
Mr. Lubnin, thank you very much for your presentation. And ladies and gentlemen, we are gonna have the last speaker, Mr. Dmitry Sheketov. I'm inviting him to give his presentation about a case study in Valhall field in North Sea.
Thank you, Suleiman. Good afternoon, dear colleagues. My name is Dmitry Sheketov, and I'm petroleum engineer in Aker BP, Norway. And today, I would like to give you a short overview of technologies we use in our company to produce and develop this giant offshore oil field, Valhall. So Valhall field has produced more than 1 billion barrels since 1992. The field is located in the North Sea, and water depth is 70 meters. So the choke reservoir is at 2,500 meters. The reservoir has good porosity and oil saturation. Typical reservoir thickness is 15 to 40 meters, and it has low permeability, 1 to 10 millidarcy. So the main drive mechanisms are reservoir compaction, fluid expansion, and line drive water flood. To produce another billion barrels, we base our field development strategy on cost-efficient operating model, which includes modern technologies for drilling and stimulation of wells, and robotics and digitalization for facilities. Today, it is about 150 wells completed in the reservoir, so drilling of new wells is becoming challenging. And the challenges are both in the overburden and the reservoir. You can see schematically wells in the overburden on the left, and map of the reservoir showing wells in the reservoir. So all new wells have to be drilled with anti-collision technologies, and their trajectories are complex. Common drilling challenges we experience are overburden wellbore instability, losses in permeable zones, and very low reservoir pressure in some parts of the field. Understanding the reservoir is a key for Valhall development. We use 4D seismic a lot, and Valhall has been a pioneer for seismic technologies, starting with 2D in the 70s, and then first stream of 3D seismic in 1992, and then 3D ocean bottom surveys imaging with both PS and PP events in 2003. Today, we have retrievable cables at the seabed, and we increase the coverage of the field. By now, we've acquired 19 ocean bottom surveys, and we call our PRM system Life of Field Seismic. This is a quick illustration of Valhall seismic evolution. This is first towed streamer data from 1992. You can see that the crystal part of the structure is poorly imaged due to presence of gas cloud in the overburden. The next is PP wave from 2013 ocean bottom survey, and you can see significant improvement in imaging of both overburden and the reservoir. And finally, PS wave from 2013 OBS. You can see that impact of gas cloud on seismic quality significantly reduced. So we use LOFs to continuously monitor depletion, reservoir compaction, and water flood injection pressure support. So this is an example, and you can see water injection with red signal around it, indicating that pressure is increasing, and nearby producer where you can see only part of the well with red signal giving indications that there's depletion in that part of the reservoir. So let's go over to drilling, and this is a reservoir section of a recently drilled well. So we drill with geosteering and ultra-deep resistivity tools to achieve upside wells potentials. So you can see that the white squares above and below the drilled section are ultra-deep resistivity tool measurements, and they are showing the top and the base of the drilled formation. So confidence in drilling of thin reservoir sections and optimal wellbore placement of lately completed 7 wells allowed us to achieve 60% higher reserves compared to pre-drilled estimates. And comparison you can see on the bar chart on the right. So it's well length pre-drilled and resource associated with the drilled wells. For drilling a very low pressure target, we used new type of mud. Nitrogen-filled hollow glass spheres were used with the drilling fluid, lowering the density to 6.57 pounds per gallon while drilling the reservoir section. That was the first application worldwide requiring an extensive lab testing and simulations prior to deployment. Pictures of the vacuum track used for testing and the hollow glass spheres are presented on the slide. So going away from drilling, I'd like to talk about stimulation. And to reduce well stimulation operational time and cost, today we're exploring single-trip multi-frac and fishbones technologies. Most of the Valhall producers are hydraulically fractured with proppant, and each fracture requires as minimum 2 coil tubing runs. This is a time-consuming and expensive operation. So the single-trip multi-frac technology allows stimulation of several zones without pulling coil tubing out of hole, and the bottom hole assembly is designed to open and close sleeves and also perform clean-out. So this concept is in the process of field testing. Now, fish bones. Conventional fish bones is an uncemented liner-deployed completion stimulation system. The technology is comprised of subs spaced out with the liner, each housing small diameter, high-strength tubes called needles. And each needle can be up to 12 meters long, and it's equipped with a jetting nozzle on the front end. The system is activated by pumping hydrochloric acid. Specifically for Valhall, we designed fish bones with solids control to mitigate choke production. So more about our pilot well you can find out in the SPE paper 195-620. Finally, a few words about digitalization and robotics. So we transform Valhall field to a cost-efficient operating model through digitalization and robotics. We liberate all field data to a common platform, make it structured and easily accessible, designing cloud-based solutions such as digital field and digital twin. Our virtual flow meters are both steady-state and transient flow simulators. We use machine learning on real-time production data to prevent wells and equipment breakdown. We're building control centers such as driller's cabin. You can see a picture on the slide. And this center will integrate cross-functional competence where real-time data will be visualized with static data and models. So our nearby future goal is to go from semi-autonomous drilling to fully autonomous drilling. And you can see rig on the slide, which we are now transforming. And our system is called Performinator. So the video is going to show how it's going to operate. So this is an animation of the drilling process. Here you can see robot taking the bottom hole assembly and bringing it to the drill center. The BHA is then lowered down to the drill center. So this is going to be a game changer for drilling, greatly reducing manpower operations and presence of people on the drill floor. So then you can see that the lifting sub is getting removed, drill pipe is connected, and everything is ready for starting drilling. This is an example of simultaneous operation of running 958 completion and building completion string. Fully autonomous robotics, pipe handling system, and control systems developed with all interfaces will greatly increase workflow efficiency. Now you can see how robot is taking 2 pipes from the deck and bringing them to the drill floor, where they are connected and ready to be installed. So reduce the number of manual operations and human presence on the drill floor will make drilling safe and efficient 24/7. So there was a short overview of the technologies I wanted to present. So thank you for your attention.
Yeah, dear Dmitry, thank you very much for your presentation. Actually, as a geophysicist, I am very pleased to see some seismic in your and Alexander's presentation as well. So your study shows that we have to combine all the disciplines, all the data to have success in offshore field development as well. So thank you very much. We have some time for a few questions, so I can get if you have any questions or comments. To everybody, to every speaker. So.
My name is Lisana. Thank you very much for your interesting presentation. My question is to Mr. Kornishin concerning ice conditions in the Arctic. There are a lot of papers saying that with climate change, the glaciers are melting, and you, as a person who is monitoring and tracking ice conditions, can you tell me whether this is true, and should we take it into account when we conduct different operations on the Arctic offshore? Most of the glaciers are really retreating as to the front. Probably about 85% of glaciers in the Russian Arctic are currently retreating, and the work which we conducted and the earlier published information show that, for instance, for Novaya Zemlya, the time of retreat of the glacier until it ceases to become productive is about 120 years. During that period, there will be 2 peaks. It overcomes the peak of its glacial activity when its discharge is maximum. From the viewpoint of iceberg condition, in theory, in the Arctic and in the Antarctic region, it will become worse and worse. Ice will become thinner. As to the warming from the viewpoint of icebergs, they will be more numerous due to retreat of the glaciers, and also due to the fact that wave conditions are also enhanced. Waves might be stronger, and the waves will erode the glaciers. There will be a greater discharge, and the icebergs will move more actively. As to the iceberg condition, it will be more intense, if we might formulate it this way.
Artem Shpakov, Gazprom and Shelf. My question is to Dmitry Shekotov concerning the drilling, automated drilling rig, which you showed. Was there any assessment concerning the economic performance? Whether the economic effect is visible from the use of automated drilling rig? And is it reasonable to use it at some brownfields, or probably it would offer more prospects at new projects? Thank you for your question. Naturally, the assessment was done, and people are working with data that are available, and the results show that the efficiency and the performance will increase due to decreasing the number of the staff at the drilling site, and this will be, and from the viewpoint of safety, it will be also quite positive. So the safety of drilling would improve,
move, and at the field such as field as Volhov, which is an old field, that will be efficient and that will be a good solution. Probably at the new fields it will also operate, but I don't have such data. As to Valhall, we gave an assessment and the work is quite intense there, so the robots would quickly be put into the operation.
Я хотел бы уточнить, компания сознательно инвестировала в эту технологию
the company has invested into this technology to increase safety and to develop the technology for other projects, or using the current assets when where it was used. Have you noted a certain effect? If you have attended the previous session, probably you know how the companies are advancing in terms of digitalization and robotics. All this needs time. Now there is a testing of robots which we carry out the facilities which I showed in the animation, and I can repeat once again that in our plans for the near future is to mount them on the drilling site at Valhall field. As to the results, that is safety and optimization of the process, increasing the efficiency and performance. Thank you. Good afternoon. My name is Yaroslav. I have the question to Alexander Vassiliev. Probably this is a more detailed question, but being a person who was lucky to participate in the project which you were discussing, how did you solve the problem? Are you doing anything with Temukhas that are forming near the platform, or do you follow the policy which the company had 5 years ago? Thank you very much. In fact, we have found a very simple solution how to combat Temukha. At our vessel, supply vessel, we use the excavator, we untouch and disconnect, and we operate, and we managed to do away with that Temukha. As to this year, we had no Temukha. Probably it was afraid of us.
Yeah, a question regarding the Valhall field, regarding the complexity of the wells, the density of it, and how we are doing it in urban planning of avoiding losing reserves or designing very complex wells. The second question is about the bone, the fish bone, how it was impacting the recovery, and what kind of percentage that you maximize the recovery out of it, and what is the way forward of the existing well and the upcoming wells.
Your question was to?
Okay, it's two questions. The first one is about the urban planning of the field. I saw a very complex field that is having lots of challenges about drilling new wells into very complex field. How we could avoid this in upcoming fields, how we could do proper urban planning and maximizing the efficiency of our slots. The second question was about the fish pond, how it was impacting the recovery, about which percentage we maximize the production out of the field.
Anyone wants to?
Okay, sorry, the question was about how we optimize the slots selection on the platforms, and the second was how we increase the recovery. Did I understand it correctly?
That's it.
Okay. Thank you for the question. As you know, that it's challenging to operate offshore field due to limited number of slots. So for us, it's important to identify the targets, and we first, of course, select the ones which give us the most, and based on 4D seismic and then extensive modeling, reservoir engineering modeling, and analyzing production data, we select the targets. So that's probably the way to optimize slot selection. And as for recovery, we started water flood in 2006, and we saw increasing recovery factor from the areas where we implemented. So that's one of the main drivers today.
Okay, thank you very much. And I have a final question to Mr. Milton. So in your final slide, you mentioned about this is just a teamwork. So one of the members of the team was academia and the students, and the universities as well. So how important to have collaboration between universities and companies like you?
Well, thank you for the question. Well, to develop these new technologies, I would say pre-salt, taking the example of the pre-salt, the new frontier, it's very far from the shore, 300 kilometers, 7,000 meters down, and it's really very complex. It's like going to the moon. So we need the efforts of the whole group of the team, no? Including academia, bringing new concepts, new basic science, new materials, and we need the help of the applied technology R&D centers that will develop together with the supply chain the adequate, appropriate equipment and new technologies to speed the process of producing. And of course, the whole is a teamwork, everybody. I would say that in our case, this very challenging project with very ambitious projects, I would say also, we are going to need lots of human resources as well as new technologies. So it's a complete teamwork, I would say, and in order to achieve this, no? And these, the new digital technologies that are coming very fast will transform the way we are going to work. And this is going to be another big challenge. That's why we need the help of everybody, no?
Okay, thank you very much, Mr. Milton. We have came to the end of our session, and I would like to thank to my speakers for this fruitful panel session and you, our guests. And just a reminder, we have some gifts to our speakers, so you can just remain in the stage. Thank you very much. Enjoy our forum. Thank you.